I hope the screen is visible to everyone. Uh, all right then. So let us get started. This is the first question. So given in the diagram at the end of the question, toothpicks have fallen. If the relation R on the set of elements, which are the individual toothpicks A, R, B. So R is the relation is 1 if an intersection if at an intersection toothpick A is over toothpick B, and 0 if at an intersection toothpick A is under toothpick B, and 0 if there are no interaction intersection. So following the following notation for over and under, so we'll have to find the relationship. So here toothpick A is over toothpick C in the given figure, and then the matrix correctly corresponding to the relation of the given diagram. So in this diagram, what does the relationship matrix look like? So they say that the relationship matrix is an n cross n matrix whose rows are of form ABCD, and cell with row M and column N represents MRN. So what do we have is basically what we'll have to create a relationship matrix R. So this is a 4 cross 4 matrix whose rows will be A, B, C, D, and columns will also be A, B, C, D. Now, what we have to do is fill in these entries. So we have 16 entries to fill. So that would give us the relationship matrix. Now, if now how to fill this relationship matrix, we'll have to use these rules. So if uh, using this rule, so if there is an intersection, uh, hello, is someone speaking? Okay. So we'll just a moment. Yeah. So we have this relationship rule. So can anyone tell me now? Just take a look at this figure. So what is the relationship between A and A? So for an A and A, just take a look at these rules. And can anyone tell me what is the relationship between A and A? You can type it in the chat box, or you can unmute yourself and say as well. Anyone? Okay, someone is saying 0. So yeah, so the relationship between A and A is 0 because there is no intersection. So given a toothpick, so it's neither over nor under, nor there is any intersection with itself. So for any such toothpick, so by this logic, what would be the value for the relation between all the diagonal in can so what will all the diagonal elements look like? Yeah, so it would be 0 because just by the same logic, the toothpick cannot intersect with itself. Now come to the more non-trivial part of this question. So what would be the relation between A and B? Can anyone take a look at the figure and tell what is the relationship between A and B? 1, right? Because A is over B. If you look at this junction over here, you can see that A is over B. So therefore 1. So since A is over B, it means that B is under A, which means that BA term would be 0, because by second rule, where 0 if at an intersection if toothpick A is under toothpick B. What would be between A and C? Right. It is 1, because again, if you take a look at this junction, it is above uh, C. So similarly, C and A, it would be 0. Again, A and D, if you look, A and D, here at this junction, A is over D, which means that A and D is again 1 and D and A is again 0. Similarly, if you fill up this matrix, what it will look like. So for B and C, C is above B. So B and C is 0, but C and B is 1, because C is above B. For B is above D, so it would be 1, and D and B would be 0. About C and D, so C and D, if you see, they do not intersect at all. So it would, both the elements would be 0. So this is the relationship matrix that we get using this. So does anyone have any doubt regarding this solution? Uh, all right then. I think this is pretty easy to understand. We'll move on to the next question. So what kind of relation is R in the above question? So again, above question is, this one is the above question. So what kind of relationship do you think R is? So relationship can be how many types? So relationship can be reflexive, symmetric, and transitive. Now, can anyone comment on whether the relationship is reflexive or not? Take a look at these rules and the diagram, and this is the relationship. So can anyone tell whether this relationship is reflexive or not? Right, since the diagonal is 0, the relationship is not reflexive. Uh, Reflexive relationship would mean that A is related to A, B is related to B, but since there is no relation, so it is not reflexive. So we cross out reflexive. Is it symmetric? What do you think? No, it is not symmetric. Yeah, so this is also right. So why is it not symmetric is because, what does symmetric mean? Can anyone tell me what does symmetric relationship mean? Just to recall what a symmetric relationship is. Right. So if A is related to B, then B is related to A. But in this relationship, it means that if, what it means that if A is over B, it it cannot be possible that B is over A as well. So if A, then if A R B exists, then B R B is cannot be possible. So therefore, this is it is not symmetric. What is a transitive relation? First tell me whether what is a transitive relationship? Can anyone explain what is a transitive relationship? Okay, yeah, you're right. So it means that if A is over B and B is over C, then A is over C. So now look at this figure and say that whether this will always hold true or not. If A is over B and B is over C, then is it possible that A is also over C? Do you think that this is a transitive relationship? No, can you explain? Okay, I'll show you a simple case why this is it won't be a transitive case, because let's say, like Akanksha pointed out, that if A is over B and B is over C, then if A is over C, then it is a transitive relationship. So let us draw some sticks. So let us say this is A. A is over B. So uh, we draw like this. So let's say we draw a stick like this. This is C. Now let us extend this stick in such a way that that it goes like this, which means that C is now over A. So such an arrangement can exist, right? So in this shows that relation is not transitive. Therefore, in the next question, it is not transitive as well. So the right answer is none of the above. So the relationship is neither reflexive nor symmetric, nor transitive. So can anyone take a moment and tell that whether it is antisymmetric or not? We haven't yet come to the antisymmetric part yet, but can anyone take a guess whether this relationship is antisymmetric or not? Yeah, so you're right. It is antisymmetric because, like in the definition of symmetric, so if A is related to B, then B should also be related to A. But in such a case that if A is over B, then it can never be possible that B is also over A. So therefore, if A R B exists, B R A cannot exist. So in such a case, it is an antisymmetric relationship. We'll come to more antisymmetric relationship in further questions. Okay, I hope this is clear. Let us move on to next question. So you have a set A. I'll write down over here. You have 2, 3, 4, 5. This is set A. And you have another set B, which is 3, 5. This is set B. R is a relation from set A to set B where elements AB exist in R only if A and B are relatively prime to each other. How many elements does R have? So before counting how many elements, let us find what are the elements of R. So Can someone uh, say what are the elements that R can have? Okay, so first let us take elements of A one by one. So suppose if I take 2, so 2 is related to which of the elements in B? Can anyone say? 3 and 5, right? So you can draw an arrow from 2 to 3 and an arrow from 2 to 5 as well, because 2 and 3 are co-prime, 2 and 5 are also co-prime. So we have 2 3, we have 2 5. 3 and 3 cannot be co-prime, 3 and 5 are co-prime again, so we have 3 and 5. 4 and 3 are co-prime. Let me draw an arrow. 4 and 3 are co-prime, and 4 and 5 are also co-prime. 4 and 3, 4 and 5. And again 5 and 3 is also co-prime. We have 5 and 3. So this 5 and 5 cannot be co-prime. So now how many elements are there? So we'll see that there are 6 elements. So it's a simple question. So that how many elements does R have? We have 6 elements. I hope this is clear to everyone. Let us move on to the next question. So we have a set S which has n elements in any relation that is created on S. So this part is basically S cross S. So a relation that is created on S, um, each element is related to itself except the kth and k plus 1th element. Which of the following are reflexive in nature? So AJ represents the jth element. So it means that if you take an element AI in S from set S, it means that AI is uh, it means this AI belongs to this relation R except when I equal to K or K plus 1. So now tell me when it would be reflexive. So which of the, if now uh, this relationship on S cross S is not reflexive because of AK and AK plus 1, because these elements are not related to themselves. So what do you think is the right answer? So uh, on which set do you think the relationship would be reflexive? Yeah, option A. So basically, the simple thing is that if you remove AK and AK plus 1 from the set S, so you remove AK and AK plus 1 and it is related to itself. So all the rest of the elements that is present in this S minus AK and AK plus 1 will be related to themselves. Therefore, this product, the relationship on this product of the set would also be reflexive. So option A is the right answer for this question. Okay, coming to the fifth question. A relation R is symmetric relation from set A to itself. So R is a subset of A cross A. Set A has n elements in it, thus the matrix of R has n square elements. Given that R is symmetric, how many entries can you delete at maximum while preserving the data of the relationship. Okay, so basically the question is that if you are given a symmetric matrix R is a symmetric matrix, which means that R equal to R transpose. In other words, Aij equal to Aji, where Aij and Aji both are are elements of R. Now, the question is, it has nothing to do with relation. So they are basically asking us that if you are given a symmetric matrix R, how many entries can you delete at maximum while preserving the data of the relation? So, okay, let me first draw a symmetric matrix to help you get the picture. So let us see R. This is, let's see, a symmetric matrix. So we have diagonal elements. Diagonal elements, uh, let us say D1, D2, Dn, and we have non-diagonal element. So here it would be, let's say A1. Because it is symmetric, this one would also be A1. So let us call it different name since we are referring elements as Aij. Let us call this um, let's say B1. This is also B1. We have B2. We have B2 over here, and so on. So this is what a symmetric matrix looks like. Now, can anyone tell me that if you are given a symmetric matrix, now how many elements can I delete from this R and still reconstruct R? Can anyone take a guess how we'll go ahead? Now the biggest hint is this, that a symmetric relationship, the element at position ij is equal to the position element in position ji, which means that if we keep only the elements above the diagonal or below the diagonal, then we can and remove the other elements. Yeah. So, and remove the other elements, then we can get back, we can reconstruct the matrix R as well. What I mean is like this. So let us take an example R of a simple symmetric matrix, say 1, 2, 3, and 3. If I give you R prime, which is 1, 3, 2, and I leave this entry blank, say, let's say I call it 0, and I give you this matrix telling that it is a R prime, from R prime to R, I give you this instruction that R prime only contains the upper diagonal terms of R, and you can reconstruct R by filling up the lower diagonal, but I don't provide the elements of the lower diagonal while passing R. What is the benefit is that I'm passing on fewer information and thus saving up on memory. So I just send the user R prime and give the instruction that this is symmetric matrix and only the upper triangular elements are present. So the user can reconstruct R easily. So now can you tell me, so they are asking that how many such elements can we remove? So here I have removed this 3. So I have removed this 3 and still I can construct back the same matrix. So can anyone tell me how many elements do we have to remove? Okay, c- just tell me this, that whether we'll have to remove the upper diagonal elements or lower diagonal elements. Uh, can anyone say whether do we do we have to remove upper diagonal or lower diagonal elements? Anyone? Just take a guess. Right, so either all upper or all lower. So you can remove either all upper or lower. So so what do you think about the diagonal? Should we keep the diagonal or can we remove that diagonal as well? So we'll have to keep the diagonal, right? So because the diagonal elements, so we do not, if we remove the diagonal elements, we have no information left in the matrix to know what are the elements of the diagonal. But if we remove the upper diagonal elements, we can construct the lower diagonal elements because they are just the reflection of the upper diagonal elements. So we'll have to keep the diagonal element. So now tell me how many diagonal elements are there? So now, uh, now number of, let us write it like this, that R, the matrix R has diagonal elements, diagonal, then it has upper triangular and lower triangular. So t- can anyone tell me number of elements in the diagonal? So how many elements in a n cross n? So n cross n matrix, we have total of n square elements. So how many of them are present on the diagonal? How many diagonal elements are there in an n cross n matrix? Right, there are n elements. So let me write it. So we have n diagonal elements. How many are there in upper diagonal and lower diagonal then? So basically, uh, to find this, we call it x and x. Let us leave it at x and x. So what happens is that total we have n square. So now in, let's say if we remove the lower diagonal, so we can remove either the upper triangular part or the lower triangular part. So total there are n square, and so we have n plus 2x equal to n square, and x is therefore n square minus n over 2. So we have to remove only x terms. So x terms corresponding to the lower diagonal or the upper diagonal. So therefore the right answer for this question is n square minus n over 2. So option B is the right answer for this question. I hope this is clear to everyone. If you have a doubt, you can ask. All right, then we'll proceed to the next question. Okay, so we have a relation R AB where A and B belongs to natural numbers. So this N stands for natural numbers, and the relationship is given that A and B are related if A plus B is divisible by 2. So let us take some examples of what could be present in R. So okay, tell me, I'll pick up some random elements. You tell me whether it is present in R. So if I pick up 1 and 2, do you think it belongs to R? No, right? So because 1 plus 2 is 3, which is not divisible by 2. Therefore, 2 and 2 does not belong in R. What about 3 and 7? Does 3 and 7 belongs to R? Yeah, right. Because 3 and 7 is 10 and therefore it belongs to R. So R is basically the sum of all so things like 1, 1, 2, 4, and so on. Uh, these are some examples. So these elements belong in R. Now let us look at whether this relationship is symmetric, reflexive, or transitive. Now let us look at the symmetric part. Symmetric. What do you think that what by symmetric? It was mentioned that if A B belongs to R, B A must also belong to R. So AB belongs to R implies BA belongs to R if it is a symmetric. So does this hold true for this relationship? If AB is divisible, AB belongs to R, which means that A plus B is some multiple of 2. Let's say 2m. What is B plus A? What do you think? It's also 2m, right? So it means that if A plus B is belongs to R, B plus A also belongs to R because of commutative property of addition. Commute. So it is symmetric definitely. Now let us look at whether it is reflexive. By reflexive, we mean that if whether A comma A belongs to R. What do you think A comma A will A comma A always belong to R or not? Can anyone say? Yeah, so it's right. A comma A y will always belongs to R because would mean that A plus A, which is 2A, is divisible by 2. Therefore, for any A that you pick, any element A that you pick from the set of natural number, A plus A will always be divisible by 2. So A comma A always lies in the relation. So it is reflexive as well. Now come to the third part, whether it's transitive or not. It means so for checking transitivity, we take AB belongs to R and BC belongs to R. AB belongs to R means A plus B is some multiple of 2. BC belongs to R means B plus C is some multiple of 2 again. Now tell me, what about A plus C? What would be A plus C? Whether it is divisible by 2 or not. What do you think A plus C will be? Can anyone take a guess? Do you think A plus C is divisible by 2? Yeah, so it is divisible by 2. So I'll show you how it is divisible by 2. It's simple. So you take this equation and this equation. So if you add them, what you get is A plus 2B plus C is equal to 2m plus n. And if you take the 2b to the left hand side, it is 2m plus n minus 2b. Now this whole thing is divisible by 2. Therefore, a plus c is also divisible by 2. Therefore, transitivity holds as well. Therefore, the right answer is it is all three: symmetric, transitive, and reflexive. I hope this question is clear to everyone. All right, we'll move on to the next question. Okay, so in the next question, it is you have given two statements. So if relation R is not symmetric, then it must be antisymmetric. If relation R can be neither symmetric, a relation R can be neither symmetric nor antisymmetric. So again, just to recap, what an antisymmetric relation is that if okay, and I'll write we have an antisymmetric. It means that if A comma B belongs to R, then B comma A does not belong to R given A uh, not equal to B. So if A and B are different, then this will always hold. So this is the definition of an antisymmetric relation. So what do you think about statement A? If a relationship is not symmetric, then it must be antisymmetric. Not really symmetric means that mm, if A comma B belongs to R, then B comma A may or mm, so wait, a better way to put a symmetric relation is like this. If A comma B belongs to R, then B comma A uh, also belongs to R. Now think about go back to your previous week's lectures and tell that what does this statement mean, that if A and B belongs to R, then B and A also belongs to R. But if it is not symmetric, so let's say what is not symmetric then, that if what is the negation of this statement? So basically uh, uh, the negation, let me write it in a different negation. What is not negation? What do you think is the negation of this statement? So if A comma B belongs to R, then B comma A also belongs to R. What is the negation of this statement? Of this statement? Can anyone say what is the negation of this statement? So it is a basically a implied implication. So this statement is an implication. So what is the negation of this implication? A comma uh, if a comma b belongs to R, then uh, b comma R uh, b comma a does not belong to R. So this is actually not the right implication. So it may look like, if we just take it on as a sentence, it might look that if a comma the negation would be if a comma b belongs to R, then b comma a does not belong, but this is not the negation. So I'll show you so let me show you with the set diagram. So let me see. Okay, so you have this set. Remember the implication lecture. So if A implies B, means that this is A and this is B. So if A implies B, means that when A is true, then B is definitely true. But when A is false, it may or may not be false. What is the negation of this is basically that when we'll draw the negation with the red. So what it means that when A is true, B may or may not be true. This is the actual negation of the statement. The first one says that if A is true, then B is always true. But the negation is actually that if A is true, then B or may not be true as well. So if you look closely, if you expand this implication, then you will wait. What do you think? So if you go back and see, if you expand it in terms of odd and, if you expand this expression in terms of odd and then take the negation of it, you will arrive at the negation. So that is how you come to the negation. So it means that if A comma B belongs to R, then B comma A may or may not belong to R. This is the actual negation. So it means that if this is true, it may or may not belong to R, then statement 1 cannot A cannot be true. Then and it is saying it must be antisymmetric, but it is the negation is actually it is may or may not. Therefore this statement is wrong. So if it was like you said, that if A belongs to A comma B belongs to R, then B comma A does not belong to R. If that was the negation, then statement A would have been right. But the actual negation is if A comma B belongs to R, then B comma A may or may not belong to R. So that is why the first statement is wrong. Second one, if a relation R can be neither symmetric nor antisymmetric. What do you think, whether this is correct or not? A relation can be neither symmetric or nor antisymmetric. Can anyone take a guess whether option B is right or not? Whether B is a correct statement or not? All right. So if you look at this relation, uh, it can be neither symmetric. So this can actually occur. So option B is a right one, because it may happen that you have taken an element A and a B. AB belongs to R and BA belongs to R as well, but not for all A comma B in the set S. So for some AB it belongs to R and BA also belongs to R, but if you take, let's say, C and D, it may CD belongs to R, but DC may not belong to R. In such a case, it is neither symmetric nor antisymmetric. So option B is the correct answer for this question. So option B is true and A is not true. Okay, so coming to question number 8. So we have an antisymmetric relation. If A and B belongs to S cross S and AB exists in R, B A must never exist in the relation given that A not equal to B. So this is by definition of an antisymmetric relation. So therefore the option is true. So if in an antisymmetric relation A and B belongs to this relation, B and A should not exist in that relation. Therefore, it is true. Coming to question number 9. If relation R is an equivalence relation on a non-empty set S with partition P1, P2, P3, P4 and up to Pn. So what do you think is the right answer for this question? So you have four options. Take a look at them and what do you think is the right answer for this question? So an equivalence relation always creates partition. This equivalence relation creates partition, which means that, now tell me whether these partitions are disjoint or overlapping. Can anyone tell me the partitions created by equivalence relation? They are disjoint, right? They are disjoint. So equivalence relationship means they are symmetric, reflexive, and transitive. So symmetric, reflexive, and transitive, all three, and it creates disjoint partition. Now take a look at this. So the first option says that you have a partition PK and a partition PK plus 1. If they are disjoint, do you think there is any overlap? What do you mean by a disjoint partition? Intersection is null, right? That is absolutely right. So the first answer is definitely correct. Coming to the second one, so P1 union P2, P3, P4 up to Pn is 5. So it means that this implies that set S is empty, but we have been given non-empty set. Therefore, this option cannot be right. So option B is wrong. See, PK and PK will, the intersection of PK and PK will always be empty. A set with its intersection with itself will be itself. So uh, PK intersection pk uh, is nothing but pk itself, and they are saying that it will always be empty. This will always be empty if pk is always empty, but pk is not always empty, right? So pk can be of any size, we don't know. So it's not guarantee that it will always be empty. Therefore option c is also wrong, and option d is obviously wrong because option a says that the intersection set is null, and option D is saying that the set will have one element in it, so which is not possible. So option D is also wrong. So the right answer is option A. Okay. Coming to the final question for our discussion today. So, equivalence relation S exists on set A, which has two n elements such that R belongs to A cross A. If the number of disjoint partition is n, what is the size of the biggest possible partition? So, number of disjoint partition is n. So you have this set A. It has been, there is a equivalence relationship defined on A. Therefore, it has been fragmented into disjoint partitions. So we'll call them P1, P2, P3 up to Pn. So n is the number of disjoint partition. So they are asking what is the size of the biggest possible partition. So what do you think about this? So if a equivalence relationship exists, so what is P1 union P2 union P3 union up to Pn? What do you think this uh, relationship is? What is the union of all the partition? Can anyone take a guess? Right. It is the set A itself. So there is nothing outside the union of this partition. So everything is contained within the union itself. So basically you have what is the cardinality? So it has, this union has two n elements because uh, A itself has two n elements. Now they are asking us, so we have total 2n elements distributed in this n partition. So you have, let's say, consider you have n boxes and you have distributed 2n elements. So what is the size of the biggest so which, suppose you have 2n balls and you are putting 2n balls in n boxes. So what is the maximum number of uh, boxes? What is the maximum number of balls that you can put in a box such that each box have at least one ball in it? So what do you think is the, so let me write this problem differently. So you have 2n balls and n boxes. How many? What is the max number of balls one can place in a box such that no box is empty? So basically, we have to solve this question. What do you think of this question? So you have two n balls and n boxes. So what is the maximum number of balls that you can place in a box such that no box is empty? N plus 1, right? So I'll explain why this is n plus 1. So what you do is basically you put one ball each in n minus 1 boxes. So you first take the first n minus 1. So may not be the first any n minus 1 box you take, and you place one ball each in this n minus 1 boxes. So number of balls left is, so total we had 2n balls, and you have already placed n minus 1 in n minus 1 boxes. Therefore total you have placed n minus 1 balls. So you are left with n plus 1 balls, and this n minus 1 ball you put in the nth box. So the nth box will have the maximum number of balls. So the maximum number of balls you can place in a box is n plus 1. So similar to this question, so what is the size of the biggest possible partition? So you can place n minus n plus 1 elements in the biggest possible partition. So option C is the right answer for this question. I hope that is clear to everyone. So this brings us to the end of our discussion. So if you have any questions regarding the solutions, you can raise your hand or you can unmute yourself and ask. You can, if you have any doubts regarding the previous questions that I have discussed, you can ask as well. So does anyone have any question? If not, you can start leaving. So we don't have any further things to discuss. So tomorrow there will be one more TA session from 6 to 8, which will discuss the same topic, but different questions will be covered and different content will be covered. Uh, Thank you everyone for taking the time to join in. If you have any questions, you can still type it in the chat box. Okay. So thank you everyone for joining in. I wish you all the best for this course and see you again next Monday.